Yeah, it's going.
Okay. All right, real quick, what we're going to do today for today's lesson is you have, you've been invited in groups and you have note cards, a pile of note cards. And all I'm going to ask you to do today, for the beginning of the lesson, you're in your group, you need to work together and you need to see, with only what you've been given the note cards, who can build, what group can build the tallest tower. Work amongst yourselves in the group you've been assigned, and that's what I want you to do. Again, don't mess around with anybody else's group. Don't try to knock anyone else's tower down. And the expectation is you're going to see what you can do, what you can come up with. You may tear them, you may fold them, you may not use any kind of adhesive or scissors. So whatever you and your group come up with, you may do so. But you can only use the note cards. So pencils and stuff, you can put those away. And you may begin. Let's see what you can come up with.
Okay, so I got you.
Alright, so first we gotta do is
and then we can like we like this. The lopsided part. And then go like this. To make that the base, yeah. And then we can go and then make them even, and then we can like, yeah. I was doing the one thing.
You should just keep, like, here. Give me 5. Oh, you already did those. No, that one's nice. No, I've been off that way.
No, you just gotta fold them, crease them down more. We should probably like put them around and then grab them flat. Yeah. Yeah, put some over here so then maybe what if yeah, let's have some more on this side so if it like starts to and then now let's put some here.
we have to put the flat ones on top.
Okay, I guess that idea. Should it still work?
Probably.
I don't think it's gonna work. Okay, I guess the car's out. Look, now we're going to see a cardboard is looks like one of the yeah, bigger base. Making it
Yeah, exactly.
yeah. Wait, we need one right side because we need to stay in the base. So we can have it.
No. We can have
Okay. Is this all the cards I get?
Yes, but
I get this one.
that one will fall apart. That.
Alright, yeah, we just gotta like
Oh no. See, like the first idea didn't work. That's not going to work. We need to fold too many. Look. Like barely can fit on one. No, we have more flats covering like a whole base. Like this. It looks shitty. That's because this one's falling in. Every time we put a new card on, it's falling.
Fail?
How do we make it? Yeah, that's what I'm doing. Like that? That's why you see too many cards. No, it's not. Look how it is when it's getting smaller, just in the beginning. But then it gets smaller and smaller. But you have more. Well, you don't need to put all of these down there. Just put like a Where? No, I did.
Alright, let's add more support at the bottom.
Here's some our tower.
Taking the prize.
I'll start stacking one. Okay, you're making this. Oh my gosh. Is the base nice and stir? Yes, mine is add more around it. What about this one? That's good. So it's straight there. Use this.
Okay.
I'm talking, can you make that smaller? Yeah. What if you got it from there? Now we later. Oh crap. Me too. I'm just here. Yes, so
This would park now.
it's the parking lot. It was close. Oh, we need a flat. Maybe we can just of course, Thomas. Okay, that's a good idea.
You need to ask yourself, what happened? What went wrong?
It was getting like
That's what you need to be discussing when you have a failure like that.
each time. Guys, how about start out? How about each time we do it? We need to write it.
You have to be careful now, guys.
So like, here's our build support over here. So like this. So that's an end, and we keep building up.
And then we double it up. Alright, nice. Oh no.
Not mess this up.
Whoa.
Sign. That's
We still have one. Alright. So this time we got to like stop like stacking them in like that. We gotta like put less.
yeah, we got to start from one side.
Yeah, because like it's tilted on that.
And we start bouncing it. If anything,
Yeah.
and then you just start straightening up.
See, that's the problem right there. The other ones are over there.
What happened here? Last time I checked, you guys had towers taller than me.
Yeah, Mark threw cards at it. I thought it was strong enough.
Well, is blaming each other part of teamwork? Okay, so evaluate the difference of what you need to do maybe to make it better.
We need a bigger base. That's what we need. That's why I destroyed it. So we can build it around it. Already finished. That works.
Oh, look at this. We got the Coliseum going here.
It's getting wobbly. Like this. We need to try this one. Next thing you know, it'll be at work. Whoa. Don't touch it. You guys are making doors. At one point, I'm not going to do it. How really long the base? This would be like nothing. Just try to I'm not blaming you. Seriously? Wow. There we go again. We just thanks, Cindy.
This is about done.
Again, you're going for the tallest tower, not the prettiest.
Something. So. Sorry, I keep thinking double E. So try to build it more that way, and someone hold the side. What? I think we need more cards. Now we need to build it up easier. No, bigger. Sydney. That's good. We're running the shapes. We are building the colors. It's building. We're gonna go down there.
Okay. Time to reinforce the base.
It's not super easy.
Jamie. Jamie. Okay, well, talk about what went wrong and what you can do to make it better.
Next time, I think we need to make the face bigger. Instead of just
Okay, just like other groups, what can you do to make that bigger? It's not confetti.
We should build a sturdier base. And we need to make sure it's more even, like on its size. Because it was just outward into
size.
It's just small. It's no, not small, because the bigger size is it also has bigger things on the
Okay, ladies and gentlemen, what we just did there with the note card lab, albeit fun, was more than just having fun. The whole principle of why we did it and what we're doing is to show you that to solve any kind of problem in any day situation, you use a scientific method. And what we're going to do now, I've given you your note-taking organizers, the graphic organizers in front of you. Going to give you the notes, and as we do these notes, now you have an actual activity in which you can relate the scientific method to, and to prove to yourself, or me proving to you, that you do use a scientific method in everyday problem solving. Maybe not the long drawn-out version of it, but an abbreviated version of it, we'll say. So, as you can see, we have an organizer here with 6 boxes. So we're going to teach you at this level 6 steps. Depending on who your instructor is, the steps of the scientific method may vary from state to state, different curriculums. But we're going to stick with the 6-step scientific method. You are in middle school. Research says you can learn 5 to 7 things new each day. So these are our 6 new things that we're going to strive to learn today. So what did we start off with? I gave you the note cards and I told you to do what? What was my instruction? What was your goal? What were you trying to get, Kayla?
Make the tallest tower possible.
You make your tallest tower possible. So right there, that was your challenge, or in the realm of science, we're going to make that, we're going to state that as stating the problem, or establishing a question. So in box 1, so you're going to state the problem. Extend outside my box here. Okay. You have a problem of any kind. If you don't have a problem, you have nothing to investigate. You have nothing to try to solve. So I gave that to you. A lot of times in science, you have to come up with your own problem. That's what you'll have to do in a few months when you start your science fair project. You'll have to submit an idea to me, and we'll see if it's something that can be solved. All right. So we stated the problem. What was the very first thing you did? I gave you note cards. I said the problem: build the tallest note card tower. You and your group. What was the first thing you did? What did you do, Thomas?
Brainstorm.
Some groups brainstorm. What did other groups do?
Started folding.
You started folding. What did you do?
My group started to devise a plan to see how we would get the tower up, and then we started to fold the cards, and then we started to build it.
Okay, so you devised a plan. You, part of your group started folding, part of you had a brainstorming. But before even that, what did you do with the problem? Now, oftentimes you think about going to the library to do this. And this is the whole idea of this fun little activity is to prove to you how you use all 6 of these steps I'm going to tell you about in daily problem solving. I'm going to tell you did research. How many of you did research? How many of you went to the library? How many of you got on your Google machine and got on the internet? Did any kind of, you got on, Caitlin? You just now got on with the library? No, I gave you note cards, you started building, right? Well, actually what you did is you did do research, okay? How many of you thought, and some of you did the brainstorm, which is a great problem solving technique, how many of you thought of you brought up prior knowledge? You thought of bridges, you thought of the pyramids, you thought of, I don't know, any structure. Maybe times you built something with mom or dad in the shop. The time mom asked you to stack dishes and you learned real quick that you shouldn't put the smallest saucers on the bottom. Because once they topple and fall over. So you did research. Now many of us think of research as being very formal. And a lot of times in science it is. We go to the library, we go to the different centers, we get on the internet. Alright? But not always. For common everyday problem solving, you should do research. You recall prior knowledge. Alright, so that next box, I'm going to try to neaten this up a little bit. That next box is going to be research the problem. So go ahead and write that in. So I'm going to start, for size sake, I'm going to start using abbreviations. So we state the problem, just the SP. Right here, we're going to call this research. Oops. Let's do this again. State the problem. Then in this box on your organizer, you did research. All right, so you have your research. What did you do next? How many of you started building? How many of you have the answer of, all right, Mr. Wallen, you're right, I guess I did do research because I recalled and thought of prior knowledge. So there's your research in a very informal venue. after you did that, how many of you started building? How many of you would say you started building? Probably the majority of you. Now this next part, if you maybe recall from your 6th grade Earth Science, were taught this in last year's scientific method, you actually did something based on your research. You thought of prior knowledge, you did your research, and then you made one of these, because this is what led your design, why you chose to do it, because you made this kind of guess. What do we call this kind of guess? Some call it a scientific guess, some call it an educated guess. You remember from last year, Alexa?
Hypothesis.
It's a hypothesis. After you find your research, you state your hypothesis. And I'm just going to write the word hypothesis in there. And on the back side of this organizer, we're going to get into the more ins and outs of a hypothesis. But who can remember from last year, how do you formally state a hypothesis? Okay? What do you think? If-then statement. Cause and effect. If this happens, then that will happen. You guys did this. You didn't do it formally, just like you didn't do a formal piece of research. You didn't go to the library and get on your internet. But in your mind, you made this, and it was real quick. Well, if I build it this way, then I can get it this tall, maybe. And it probably wasn't maybe even worded correctly with the if-then statement. Okay? After we're done with the scientific method, I'll teach you how I want you to apply the word because after your if-then statement, because that provides the scientific rationale and explanation as to why you believe in your educated guess. We'll get to that in a little bit. But for right now, we state the problem, we identify the problem under investigation, we do the research, we state the hypothesis. Again, in a matter of seconds. After I gave you the problem, you did these two in a matter of 5 seconds probably. And now we're ready to move on. So what do you suppose, this box down here, what did you do? This is the answer everybody who's been wanting to give me all lecture long. Liz?
We did it.
You did it. You tested it. You performed the experiment. Right? Everyone built something, right?
Yeah.
So you tested it. Test, perform experiment. However you need to word it to remember it. And there's multiple words you can put in these boxes, and we're going to see in a few minutes why we can use multiple synonyms and words, because we're going to make a little, maybe a memory device to remember the order. We'll do that after we get the information out. State the problem, you did your quick recall, your research, you made your guess, and then you built. From here to here was a matter of seconds. There's 6 steps. We're halfway through the scientific method. That quickly. Many of you come in, and even in the 6th grade with that maybe negative thoughts of the scientific method being a long, drawn-out process. But it's actually a process you're actually very good at. Anytime you solve a problem, this is what you do. So we tested it. We have 2 more boxes here on your organizer. What did you do after you tested it? Oftentimes, if you're thinking of a scientific lab or a field study, the scientist gets out the journal, starts writing in numbers, maybe takes some pictures. What do you think that's called? Alani.
Record your data.
Okay, how many of you had your scientific journals out or your notebooks out? How many of you recorded your data? No one did, because if you did what I asked, you hey, cleared your desk, you didn't even have that available. So I guess you skipped this step, right?
Yes.
No, you didn't skip this test. How did you record your data? Where did you record your data, Jacob?
In your mind by talking it out.
You shared information, you talked with your group members, you stored it in your mind. How many of you built something differently? And as I was walking around the camera, you could see some of you had one design and it fell over. And you built it differently. Why did you build it differently? What did you do in your mind right before that tower fell?
We saw that the structure was unstable and that we should change it.
Okay, you saw the stable or the unstable structure. You took a mental snapshot, didn't you? Now, it might be something that you're not going to be able to access after a few months, but it was a mental image of your tower right before it fell. And you're left, now you can, like Jacob said, discussing with your members, well, on my side it was leaning this way. I think, well, maybe the base needs to be a little bit wider. Then you recall some more. The pyramids are built that way. And right there, you're making, well, I don't want to get too far ahead of myself. You do your test, you made your observations, right? Okay, so I'm going to put OBSER. Obviously, your boxes are a little bit bigger. You make observations. What do you do with these observations? So you decide, okay, well, I built it this way and it fell over. It only got about yay tall. What'd you do with those observations? Yeah, and we call that when you finish up a project or any one test, changing a few variables or changing only one variable. What do we call that? You draw your what? Yeah, you make a conclusion. You make a conclusion. And without much time passing, real quickly, from your conclusion, you go right back. You know what the problem is. It fell. I got to quickly build another card tower before the time falls out, or time runs out. So you skip that and you go back to your research. Well, now, guess what you have to add to your research? You have your first tower that fell over, your first experiment, your first trial, your first run of it. You add that to your mental research. Now you're saying, well, I built it this way and it didn't get very tall, it kept falling over. So you know what not to do, you're going to try something different. So you come up with another quick mental hypothesis. Well, I built it this way before it fell over, so if I build it this way, then maybe I can build it, maybe it'll go a little bit taller. So you then have a new hypothesis, and you build it again. How many of you rebuilt your towers? Yeah, I think everybody did in here. A group of girls over here had a very solid foundation going, a very good idea. And then it fell again, you made an observation. How many of you changed your design from the first one you built to the second one you built? Yes, absolutely. I think everybody did. So we started this day off with, here's some note cards, build a tower, see who can build the tallest tower, go, have fun. Alright? And raise your hand if you thought that was a fun activity. Good. And the point I'm trying to prove is, the scientific method can be fun. Science is fun. And you apply the concepts of the scientific method every time you're given a problem in which you need to solve.